Hi everyone, welcome back to the channel Code with AKJ. Today is day 2 of solving LeetCode 75 challenge and today's question is greatest common divisor of strings. So the question says here for two strings s and t, we say t divides s if and only if s is equals to t plus t plus t plus t and so on. That is t is concatenated with itself one or more times. So given two strings, string 1 and string 2, we need to return the largest string x such that x divides both string 1 and string 2. So the problem here is we are given two strings, string 1 and string 2. The task is to find the largest string x such that it divides both string 1 and string 2. So when we say a string t divides another string s, it means s can be formed by concatenating t multiple times. So for example 1, the string 1 is ABC, ABC, and string 2 is ABC. So in this case, if we try to concatenate string 2 more than one time, we can achieve string 1 here. So if we try to concatenate string 2 two times, in this case, which would be ABC and ABC, we'll get our string 1 as ABC and ABC. So hence, we need to find a string x which will divide both string 1 and string 2. So in this way, we can say that ABC is the largest string which divides both string 1 and string 2 in our example 1. So example 2, the string 1 is AB, AB and AB and string 2 would be AB and AB. So we need to find a string x which would divide both string 1 and string 2. So in this case the answer would be AB as AB is present in both string 1 and string 2. So in example 3, as you can see, there is no common particular string x which will divide these two strings. So in this case, we need to return an empty string. So let's try to start with a brute force solution. We know that greatest common divisor GCD of two numbers is their largest divisor. Similarly, in this problem, the greatest common divisor of strings will be the largest string x that can divide both string 1 and string 2. So one brute force way to find this to check all the substrings of string 1 and string 2, and for each substring verify whether it divides both strings or not. So the largest substring that satisfies this condition will be our answer. So let's try to dry run this particular code. Here I have written both string 1 and string 2, and we need to find a string x which would divide both string 1 and string 2. So if you try to observe these two strings carefully, we can see that ABC is a string which would divide both string S1 and S2. We can see that ABC is present in both S1 and S2. So we can declare that this particular ABC string can be our possible X value which can divide this both S2 and S1. So in this case our answer would be ABC. So if we take another string S1 as AB, AB, AB and S2 as AB, if we carefully observe these two strings, we can see that AB is a largest string which can be our possible X value where S1 and S2 both contains these AB. So in this case our answer would be AB. So in this way we need to find a largest string X for which both S1 and S2 gets divided by it. So the brute force approach here would be to generate all these substrings for this both S1 and S2, and we'll parallelly check whether that particular substring can divide both S1 and S2 or not. So let's move on to the code, and later on we'll find out our time complexity and space complexity for this approach. So this is the code for the brute force approach we have discussed, where I have taken the size of both strings. I have taken a result string which would be initially empty, and as we have discussed, we need to generate all the possible substrings of these two strings, and we'll check for each substring whether it divides both S1 and S2 or not. So I have taken a for loop. I have created a substring which goes from 0 to I using the substr function, which could be our possible candidate. So we'll check whether this particular candidate gets divided by both like S1 or S2 or not. So we'll take the help of a function called divides, where it will check whether this particular candidate is getting divided by S1 or not. So if it divides both S1 and S2, we'll store that particular candidate, and in our possible string result and finally we'll return our result from this function. So if we try to look into our function bool divide, which will check if string t divides string s or not. So we'll take the size of both strings s and t. We'll try to check whether the size of both strings are divisible or not. So we'll return false from this step. So we'll take a string repeated, which would be initially empty, and we'll try to concatenate that particular string t. So after finishing it, we'll try to check it with our original string s. So after concatenating string t m by n times, if it gets equal with string s, it means it is dividing it. If not, it will return as a false from the main function. And if both gets true, so if this particular candidate divides both s1 and s2 successfully, we'll store this particular candidate in our result variable and we'll finally return that result variable. So let's try to run this code. So let's submit. As you can see, it got successfully accepted, but here the time complexity would be O of n square, where n is the length of the string. So the issue with this brute force approach here is it works, but it is inefficient. We can optimize this problem further. So here the optimal approach here would be to, instead of checking all substrings, let's use the property of GCD to simplify this problem. So if there exists a greater common divisor string x, it must be a prefix of both string 1 and string 2, and it should divide both strings entirely. So we can use the Euclidean algorithm for strings to find the GCD of two strings. So if str1 plus str2 is equal to str2 plus str1, this means that both strings can be formed by repeating the same substring. So for example here, if s1 is abc abc and s2 is abc, our Euclidean algorithm suggests that if s1 plus s2 is equal to s2 plus s1, we can say that these two strings can be formed by repeating the same substring. So here s1 plus s2 would be abc plus abc and then abc, and s2 is abc plus s1 is abc abc. So as you can see, the LHS is equals to RHS, which means this algorithm is working fine in this case. It means there exists a substring which divides both s1 and s2 here. This particular substring s1 and s2 has a substring x which can divide these two strings s1 and s2 entirely. And our second step here would be to find this particular largest string which would divide both s1 and s2, and which can be found using main function called GCD of length of s1 and length of s2. So there's an inbuilt function called GCD present in C++, which will help us to find the largest substring length of both s1 and s2. So let's try to code this particular approach, and as you can see that it is more efficient than our brute force approach, where we try to generate all the possible substrings of this both s1 and s2. So this is a code for the optimal approach we have discussed, where we first make sure that it contains substring or not from these both s1 and s2 by using our Euclidean algorithm, where if str1 plus str2 is equal to str2 plus str1 or not. So if they are not equal, we'll return an empty string from there itself, and if there exists a substring, we'll find the length of that particular substring using our GCD inbuilt function. And since we need to return that particular substring, we'll take the help of substring function, which will help us to find the largest common divisor string using this particular GCD length, and we'll return that particular string value from the main function. So let's try to run this code. It's working, so let's submit. As you can see, this problem got accepted successfully and it is more efficient than our brute force approach. So here let me explain this particular code once again. So first we check if str1 plus str2 is equal to str2 plus str1 or not. If not, it means no common divisor string exists. And then we compute the GCD of lengths of both str1 and str2 using the Euclidean algorithm. And our answer would be the prefix of str1 of length GCD length. So here the time complexity of this approach would be O of n plus m, where the n and m are the lengths of str1 and str2, and this is much more efficient than the brute force solution. So to sum up, the brute force solution works, but it is inefficient as it checks every possible substring, and the optimal solution leverages the properties of string concatenation and GCD algorithm to efficiently find the greatest common divisor of the two strings. So if you found this video helpful, make sure to hit the like button and subscribe to the channel for more coding solutions. Drop a comment if you have any questions and let me know what problem you'd like me to cover next. Thanks for watching and I'll see you in the next one.